is known as a dilation. In a dilation, the size and position change, but not the orientation. So size and position will change when you dilate a figure. Orientation will not. All right, so dilations come in two types: enlargements and reductions. Enlargements get bigger. Reductions get smaller. Okay, so if you see an enlargement, you'll know how to look for it. It's bigger, get bigger. Reduction gets smaller. All right. The scale factor indicates how much a figure will enlarge or reduce. Technically speaking, this is Module 10. That's what we've entered into. That's why there's so many new vocabulary words here, such as scale factor, enlargement, reduction, blah, 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 blah. The scale factor is always going to be represented by the same variable, the letter K. Whenever you see K, and we're talking about rotations, transformations, reflections, dilations, whatever, K represents the scale factor. In case you forgot, I want to see if you remember. Which symbol is that? Less than. Something like, In case you forgot, I taught this to you earlier in the year. If that's an arrow, which way is it pointing? To the left. So we write the word left. What is the first letter in the word left?
L.
Which is also the first letter in the word less. That's the less than sign. So if you know this is less than, that means this has to be the greater than sign. You'll be surprised years from now it'll come flooding back into your head when you're taking some college entrance exam or something. Which one is it? Less than, the arrow points to the greater than, yes! Yes, I can go to BC. Okay. So, when K, the scale factor, is greater than 1, that will be an enlargement. So if you're ever presented with a scale factor that is greater than 1, like 2, 3, 4, 5, 6, 7, that is going to be an enlargement. The figure will get bigger. When K is less than 1, the dilation will be a reduction. We don't use decimals for scale factors, not for this. So if it's less than 1, it'll be a fraction, like 1/3, 2/5, 1/7. If you see a fractional scale factor, might be a reduction. Now be careful, because you could see a scale factor like 3/2. Is 3/2 greater than 1?
Yes.
Yes, it is. Is 1/2 greater than 1? No. So just make sure you identify the fraction. So, lots of vocab. Let's see if you remember how to identify the preimage and the image. So we're looking here. I want everyone to look here. You should, either by looking here or looking at your paper, be able to tell me right away, was this an enlargement or a reduction? An enlargement. And you can tell that even without this written in your paper by looking at the figure. Look at the prime notation. So this tells me I started here, A, B, C, D, and I ended with A, B, C, D prime. Which means that this figure, we took it, made it larger. So if we got larger, that means the scale factor has to be what? Greater than 1. Thank you. We go to this one right here. We look at the prime notation. Okay, so this is the one with the prime notation. So that is our image. That's where we ended. That's my preimage. That's where I started. Did this figure get bigger or smaller?
Smaller.
Smaller, which means that here, the scale factor had to be less than 1. So, K greater than 1 gets bigger. K less than 1 gets smaller. What if K, scale factor, was equal to 1?
It stays the same.
Stays the same. It stays the same. All right, so to dilate a figure, we multiply each vertex of the preimage by the scale factor K to identify the vertices of the image. So when you want to dilate a figure algebraically, it's simple. How many of you can multiply single-digit numbers? Good. All you have to do is take each of the coordinate pairs of each vertex and multiply it by the scale factor. So in this one right here, we're given the scale factor, K equals 3. If K equals 3, is this going to get bigger or smaller?
Bigger.
It's going to get bigger.
It's not a
The
negative.
coordinates will get bigger. Coordinates. These things here, these numbers will increase in size. So this is an enlargement. Very simple. Now, I was nice here. I went in and identified all the coordinates for you. Usually, you would have to do that for yourself. So you have to go and you have to find what was S, what was U, what was T. At the same time, I did that. All I want you to understand here is to dilate this figure, simple process. You're going to take each one of these coordinates and you're going to multiply it by the scale factor. What's my scale factor? 3. So it's simple multiplication. This is 0, 1. What's 0 times 3?
0.
What's 1 times 3?
3.
3. So 0 times 3 and 1 times 3, that gives you s prime at 0, 3. It's simple multiplication. I use the star here because I don't have a little dot or x as a variable, so just know that that means multiplication, multiplication. Once you do the multiplication, you're going to go and graph the prime point. So it goes from here, we go up to 0, 3. 1, 2, 3, and that is going to be s prime. And you're going to repeat this process for t and u until you get the coordinates of t prime and u prime. Same scale factor. So I'm going to take 3, 3, and I'm going to multiply both of those by 3. That gives me t prime, which is 9, 9. So we go. This is the origin. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is my t prime. I go to you and Matthew. What am I doing to you? I'm multiplying both coordinates by my scale factor, which is? No, what's my scale factor? It equals 3. My scale factor is 3. So what's 2 times 3? And what's 1 times 3? Perfect. So we multiply, and I get u prime at 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. And that gives me u prime. Once we have these graphed and labeled, always remember to label them as you go. STU, S prime, T prime, U prime. Connect them with lines, and you've done your first dilation. It's just that simple. Simple multiplication. Now enlargements are easy because usually they're whole numbers. Occasionally you run into an enlargement that's a fraction. Usually fractions will be reductions. If we look here, we have a figure that has a scale factor of, that's not a pen, a scale factor of 1/3. That immediately lets me know this is not going to be an enlargement, it's going to be a reduction. So we're going to take this figure and we're going to shrink it, which means we have to take each vertex, take the coordinate pairs, and multiply it by 1/3. This is not something you're going to be doing on a calculator. In case you forgot how to multiply something by 1/3, allow me to show you. So we're going to work with B. Identify the coordinates for B at 3, -3. So let's go here. We have, this is B, and this is 3, -3. For right now, I just want you to pay attention. You can write it down in a second. So my scale factor is 1/3, and I'm trying to identify B prime. Here's what I do. I take this, the x coordinate, 3. I'm going to multiply it by 1/3. Can you multiply a whole number in a fraction? No. So we must turn this into a fraction by putting it over 1. Once you do that, you simply multiply straight across, straight across, straight across. What's 3 times 1? What's 1 times 3? And divide. 3 divided by 3 is 1, which means that the first coordinate here in B prime is 1. It's just that simple. Don't do this with a calculator because on your FSA, this problem that you're presented with here, you will not have a calculator for. This is on session 1, no calc. You have to know how to multiply like this. They expect you to know that in 8th grade, so make sure you do. Simple multiplication, single digit numbers. All right, -3 now, same process. We put -3 over 1. We multiply that by 1/3 equals -3 times 1 gives me -3. 1 times 3 gives me 3, and then we divide. -3 divided by 3 gives me -1. Because when you divide, a negative and a positive give you a negative. -1 is my y. Yeah, now you can write this down. Write this down on your paper somewhere. If you're not 100% sure how to do every single step here, write it down on your paper so you have access to this when you're doing your homework. Wait, how do you multiply? Because you're not going to be able to do this on your calculators. Not for repeating decimals, at least. Terminating, you might be able to get away with it, but I would recommend that you practice doing this. Okay? Give your life 10 more seconds. Good thing is this is the longest slide. Last 2 sections are pretty short. We got it? Okay. All right. So we know that this is 1, -1. We're going to graph that right there at B prime 1, comma, negative 1. Anybody work ahead and get into the other coordinates?
I think I have D.
Okay, what do you think D prime is?
3, negative 5.
Perfect. 3, comma, negative 5. Same process. We take both of these, multiply them by 1/3. You would end up with 3, comma, negative 5. So we go to 1, 2, 3, down. 1, 2, 3, 4, 5. That's going to give me D prime. Anybody have E or C? Savannah, what do you got?
1, negative 4.
1, negative 4. Good. And Deborah, what do you have for C prime?
4, negative
4, comma, negative 2. Good. Once you get all those points, you want to go in and you want to graph them, label them, and then play connect the dots. So I've done B prime and D prime. I'm going to do E prime, which is 1, comma, negative 1, 2, 3, 4. That is my E prime. Make sure you label them carefully, because if you mess up one of the labels, the B, the C, the D, or the E, the whole thing's wrong. We're going to do C prime. 1, 2, 3, 4, down 1, 2. That gives me C prime, and I can go in and play connect the dots to finish off this reduction. 1, 2, 3, 4. The shape did not change. I have dilated. What is this? This is BDEC. I reduced it to BDEC prime. Any questions on this at all? I don't think so. You can check your. Questions? Questions? Are we sure? You have to do one on your own in a second. Okay. Okay. So far we have been doing dilations, enlargements, or reductions. We only had one figure. We usually had the preimage. We had to go find the image. If you notice here, we're given the preimage and the image. The dilation's already been done. Now, that's not what you're being asked to do. What you're being asked to do is identify the scale factor. In order to do that, and we'll help this with a pen, in order to identify the scale factor, we once again will use a set of corresponding vertices, aka corresponding points, such as A and A prime, B and B prime, C and C prime, so on and so forth. You get the idea. This is the same way you wrote rules for translation, so on and so forth. You get a set of corresponding points, such as H to H prime, G to G prime, I to I prime. You have to identify those first. Once you do, you should know the answer to this question. To dilate a figure, we have to multiply it. The reverse, finding the scale factor, that means we should probably have to divide. So to find the scale factor, we're going to be dividing. Simple division. You're either going to divide the x-coordinates from your corresponding vertices, or you're going to be dividing the y-coordinates. You only have to do one. You can do both if you want to check your work. So the first thing, once again, is to identify corresponding set of points. I'm going to circle G. What is the only point here that corresponds to G? Guys, which one? G prime. So we're going to work with G and G prime. Once you identify your corresponding points, you identify their coordinate pairs. G is 1, 2. G prime is 4, 8. And then this is where I need you to pay attention. You know how to do that. You know how to do this. This is the place where most people make mistakes. To find the scale factor, you're going to be dividing. So we're using a fraction, right? The question is, x's or y's. It doesn't matter which one you use. Let's say we want to work with the x's. That's a 1 and a 4. So we have two numbers. Which one do you think will always be the numerator? The preimage or the image? Which one?
Preimage.
Not the preimage, the image. The one with the prime notation. Which one of these, 1 or 4, is the prime coordinate? 4 is the prime coordinate. That's G prime, so that's the prime coordinate. So the prime coordinate is always going to be your numerator in that fraction. And I'm going to show you there's a really easy way to figure out if you did it wrong. So 4 is my numerator, which means that 1 is my denominator. Then it's real simple. What's 4 divided by 1? 4. So your scale factor is 4, and you're done. If you're not sure if you did this correct, try to look at the y's. So what is the prime coordinate for y? What is it? 8. The other coordinate for y is 2. 8 divided by 2 is 4. And here's another way to check your work. If we look here, this figure, did it get bigger or smaller? This figure got smaller. It got bigger. Which means if it got bigger, your scale factor has to be what? Greater than 1 or less than 1? Greater than 1. If you do this backwards, instead of getting 4, you're going to get 1/4. That lets you know right away. Wait, hold on. This got bigger. Why is my scale factor less than 1? I must have made a mistake. So you go back and you check your work. It's always the prime coordinate as a numerator. The other coordinate will be your denominator. X over x, y over y. All right? Let's try one from start to finish. Right here. Who wants to help me? Deborah. Thank you. Thank you. Thank you. Thank you, Deborah. Deborah, give me a set of corresponding points.
V
and V prime. Okay. So give me the coordinates for V. Comma, and I'll help you out. I'll give you the coordinates for V prime. V prime is 10 comma 2. Perfect. So now that we have that, I'm going to leave Deborah for a second. Gael, to find the scale factor, you want to work with the x's or the y's? The x's. Okay, so we're making a fraction. What number? You have 4 numbers here. Since you're working with the x's, that takes you down to 2 numbers. What 2 numbers are we working with here? You're working with the x's. Perfect. Those are your x's, 10 and 15. Which one of those is your numerator? Remember, the numerator is always the what? Which coordinate, guys? The prime coordinate. So you're working with the x's. Which x is the prime x? 10 or 15? Look at the notation. That's the prime notation, right? So it's 10. And the other one is your denominator. Can you simplify 10 over 15?
Yes.
Down to what, guys?
2.
2 over 3. 2/3. So your scale factor here is 2/3. If you want to check that, go look at the y's. What is your y prime coordinate? The class, what's your y prime? 2. That means your other coordinate is 3. You can't simplify that, so your scale factor is 2/3. So k equals 2/3. If you want to fact check yourself, look. This figure, this is the original one. The prime one is bigger or smaller? Smaller, which means my scale factor has to be less than 1. Has to be less than 1. This is less than 1, so most likely you are correct. Any questions on this? All right, last part is the simplest. We are going to be writing algebraic rules for dilations. As always, we use coordinate notation. This is the template. Please pay attention here because it's really simple, easy to be like, it can't be that simple, I must be making a mistake. What does K represent? K represents what?
Scale factor.
Scale factor. So this is the template. It means that when you write a rule for a dilation, you're going to find the scale factor. So let's say in that whiteboard, the scale factor was what? 2. Once you find the scale factor, you simply replace the K's with the scale factor. So for that last whiteboard here, the scale factor was 2. We agree?
Yes.
Which means that to write a rule for this, instead of writing kx, comma, ky, these are both replaced with what number? 2. So the rule for this would be 2x, comma, 2y. Simple, right? That's really it. There's no tricks. We're going to do 2 of these together, and we're going to see. Now this, if this looks familiar, it should. You saw this on the very first slide today. I told you that the scale factor was greater than 1. But I didn't tell you the scale factor. Let's see if you can find it quickly. I have a, 1 comma 1. I have a prime, which is 3 comma 3. What's the scale factor? 3. So my scale factor is 3. X prime divided by x, 3 divided by 1, gives me 3. Now that I have them, let's see if you can piece it together. I take the k's out, I replace them with the scale factor. What is my rule, class?
3x, 3y.
Beautiful. 3x, comma 3y. That's it. You're simply replacing k's with the scale factor. It is super simple. Class, looking at this right here, I'm not going to assist you in any way. Was this an enlargement or a reduction?
Reduction.
Good. Anybody have the scale factor? Anybody have it?
I think it's half.
It's 1/2. Perfect. Scale factor is 1/2. which means I will give you the reciprocal in that. 2 tickets if you tell me what the rule is right now.
Wait, hold up.
Take out the case, put in the scale factor. What do you got?
X minus.
No, that's a translation. Alright, focus up here. When we're doing dilation, stop. Keep the marker out. That's a distraction, it means you're not paying attention. Okay, we take the case out, replace them with the scale factor. So this K is gone, it's replaced with.
1/2.
This K is gone, it's replaced with. So my rule is what?
1/2 X, 1/2 Y.
Boom, it's just that. Don't forget to like the videos, leave a comment, share it with your friends, and of course, subscribe.